Let me first copy this into the...
So just run it from the stick.
Let me know where we begin. Yeah, we're just...
Oh, ich hab da mal was. Achtung, Achtung. Ja.
Yes, excellent. Only
so then right up no, left stop, and the primary one should be the local one, right? Let's try this.
Well, it doesn't matter.
What the hell?
You're a funny guy.
Can you copy it?
Does it work?
Start presentation. Why doesn't it work?
No clue what you're doing.
You ready?
It's already working.
It's already working.
What are you doing?
I don't know.
What are you doing with my notebook?
Are you streaming it? Now it's working.
Are you gonna stream it?
Yeah, I
Tried it. Okay.
Whatever.
You ready? Okay.
Okay. Hi guys. We're here to give you an overview of what happened in OSR in version 1, that's me, and version 2, that's Henning, in the past year and what the plans are for the future. This is me. I'm self-employed. I work on OSR. I'm paid by a contractor to do that. And I also commit in several other projects, mainly OSGI, with Java-based framework. Okay, what happened in last year? We had some releases. I made a nice graph. And if I estimate, we'll end up here somewhere in July with a new release. Well, actually, we're probably going to accelerate that. Probably this week we'll have a new release. And there's some major features in there that we'll discuss. We have a new release model. So previously it was sort of like we do an ad hoc release Now we formalize that a bit more. So at one time we have like a state that we say, well, shall we release this? So we start branching off here. So we introduce the stabilization phase. We create a release branch, and then we will release from that. So it's a bit more formalized, and we do not stop development on master because we just want to release some stuff on the side. This is the current picture. So we have 2 running releases, 064, 065. There will be a new release on 065 this week probably. And master has accumulated several fixes that we will likely branch off for a new release. What happened is Jenkins. Anybody know Jenkins? Continuous integration. Use it. It is very, very valuable.
I can tell you Jenkins is annoying. This thing sends me an email every time someone commits something, including me, and suddenly the stuff doesn't compile anymore. And it says, hey, do something about it.
You broke the build, fix it. Okay, so this is a screenshot from my personal build server. Only the OLSR version 1 builds I have in there. So basically it's split between master builds and release builds. I only built the latest release branch, but you probably can't read it, but I have Linux builds in there, 32-bit, 64-bit. I have Windows builds, 32, 64. I have an Android build in there, and I'm planning to put an open WRT build in there if I have the time. So we build for all kinds of platforms, and every commit is built, so we make sure we don't break any platform we want to support for any push. So use it, it's valuable. Okay. On my contractor, the platform we run on is Debian Squeeze based. It's Voyage Linux, and for Jenkins, Debian Squeeze actually sucks. The software is very old, and multi-arc actually does not work at all. So we need 2 build machines just to be able to build Linux 32 and Linux 64, which kind of sucks. The screenshot you saw was from my personal build machine, which is a Fedora machine. It has no problem cross-building anything. What happened is Coverity. Anybody heard about Coverity? Yeah? For the others, Coverity is a commercial company that does static code analysis. If you're an open source project, which we all are, it's for free. So you just apply, you get an account for your project, and you can submit builds. And every submit, they analyze your code base for errors like null pointer, dereference, etc., etc. It's free. So I would advise anyone to apply it because it's high quality code analysis. It will improve your code base a lot.
At least if you fix the bugs they find.
Yeah, okay.
And
That's this picture.
Okay.
So when we started out, it was like October 2012 we applied, and we had over 100 hits in the tool. The hits doesn't mean it's an actual bug or failure to code something. It's a hit. It can also be a false positive. So in the beginning you see a very steep ramp. These are easy fixes. So you go down below 30 very fast. Then you have another few steep ramps. And then you have a very long, nothing happened over there. Well, nothing happened over there means 2 things. We didn't have the time to work on the issues. And second is the issues were very complicated. So the tool finds very easy things to fix, but it also finds very complicated stuff. So that took us a while, but now we're down to 0 hits in their tooling.
What kinds of fixes?
Wow, from null pointer dereferences up to race conditions. We had a race conditions when we were pulling files in some place.
Because also they do some kind of flow analysis, what kind of ways your program can run through several conditional branches, and then sometimes they say, okay, yes, and if you have this kind of combination of variables, then you have suddenly an uninitialized variable. And you say, wait a moment, I initialized there and there and there, but somehow there's some way to get through, and somehow they manage to see this from the source code and tell you, wait a moment, here's a condition with this kind of input, you get there, and they tell you, we think this is a problem, and then at least you have to look into it. So some of these problems took a while to find out what the hell was going on, and even longer to fix this stuff. But it's again similar to Jenkins. It's a very valuable tool because you can make sure that your code gets most likely a little bit safer because you avoid some pit traps, and you don't reintroduce them because with the new because they scan your code regularly. So when you new commit, you can instantly send them new versions. I think we even automated this. So when we commit things, we send them, yes, we have a new commit. They pull the commit and say, yeah, you introduced a few problems there.
My Jenkins server has a special build for Coverity. So every time we push, my build server submits to Coverity the build.
Ask if somebody is using it already from the other project.
I don't think anybody's using it, right?
Yes, we do.
Yeah?
Yeah?
Yes.
Good idea.
We had only 3 little things that it found our code and we fixed it a day later.
Excellent.
We were luckier.
Yeah, excellent. So to the other projects, apply and use it. It's high value. Then position update distribution. This is my plugin. We deploy OLSR in a crisis management scenario. So that means like police, firemen, ambulances, government organizations, they manage the crisis in their area, and they need positions. So how does it work? We have GPS that goes into the GPS daemon. It multicasts on the LAN. My plugin listens to that and multicasts it over OLSR. Very simple, basically. Only it's not, if you look in the code. This is basically a quick screenshot. You can't read it, but it shows all the GPS information that the node has. It's in the web interface. You can go to Google Maps. The crisis management software I don't have screenshots of, but you can see all the positions of all the vehicles. Then we have a relay server, which is kind of nifty. It does this. Very simple. For position information, we link the networks that are not connected. So this network can see all the positions from that network and the other way around. So how does that work? All the nodes in this network, they push their position into the relay server. Same here, but the downlink works a bit differently. We use Smart Gateway to select a sort of cluster leader, so who's the boss for position downlinks. And the relay server only sends a single stream to a single node. And that node just redistributes it in the network. So that's for downlink efficiency. This is a picture from the relay server that I made very quickly to identify that we have multiple disconnected mesh networks.
So mesh islands, yes?
Yes, but actually they're not islands, they're just geographically so far away, but in the same operation. So they have to know their position information, but they're not connected through the mesh. So we uplink them through the backbone. Multi-gateway for Smart Gateway. This is the next talk. This is quite a big thing. and it's a stepping stone into solving the breaking connections problem, which I will explain in the next talk. Major cleanup, fixes, whatever. Smart Gateway Dynamic Speed plugin was added. Anybody use Smart Gateway in OSR? Nobody? Yes? We like it. Apparently other people are unaware what it can do for you. Maybe that will change in the next talk. This last plugin, you can watch a file, and in the file you define what your uplink and downlink bandwidth is, and OSR will just adjust to those values, so it will advertise different link speeds. We use that in our Avaya vehicles because we have different uplink methods. We have 3G, we have SATCOM, we have beams, so depending on where we are and what method of telecommunication we deploy, we change those speeds. So the nodes in the mesh can switch gateways if the speed goes down too far. Or if it goes up, it switches to the fattest part. We made it a bit more dynamic. MDNS, Severio, you guys did a lot of updates.
Yeah, we had a student working for Google Summer of Code, and we cleaned up a little bit the problems of the MDNS plugin. Basically, we had a loop condition that if the plugin was not well configured, you could cause a loop of MDNS packets. So now this is handled by default. And then this is the router election. Basically, what happens is that if two routers are doing the MDNS stuff in the same LAN, there is a router election mechanism. So only one actually does the work and the other one is silent. It's like backup. And then the host filtering means maybe you have the MDNS plugin on your OSR router because you want to share some service that you have in your LAN, but you don't want to share everything. For example, I don't know, I have my Apple Airport access point. I don't want all the community to access to it. And so you can filter out what you want to announce or what you don't want to propagate in the mesh.
The router election is also something that's a problem in our network. So we have multicast, the same difficulties as you solved in that plugin.
Yeah.
So there's a JSON plugin added by Hans from the promotion guys. It's basically a straight copy of text info. The task plugin was removed by me because it was actually unmaintained for over 3 years. And when I tried to upgrade the Lua library, and it was complete fail, so we just deleted. Nobody used it, to our knowledge. This seems minor, but for us it was actually pretty big because all those are forks, and then we have to kind of wait in the startup script until it forks and then detect the PID. So we had startup hassle. And the build was actually very much improved. It became more silent, many warnings were removed, etc. There's some coding issues, however. There are not many contributors. Basically, you're looking at the two most active guys here. So we commit what we want, basically, but that could be a challenge for quality. We try to do it right, but sometimes stuff slips through. So if you're using it, please try to get involved into the code base because we need you guys to keep the quality high. And the last thing that's actually a pet peeve of mine, there is much code duplication. We have basically 3 plugins that do something with multicasting, and Dan Staples, is he here? Hi Dan, you proposed the 4th one. So that for me was the limit. We need to talk on how to merge this stuff. It's getting troublesome. And we have basically the same for the text info, the HTTP and the JSON. These all look very much alike. We need to merge them. But maybe that will not happen in version 1 because version 1 is sort of trying to be version 2. We're waiting for Henning. So Open source, of course we are, always are, and the uplink server I just described is here on the AHR project. That's our project. We use a NMEL library and the uplink server is all open source. Okay, then the most important part of our plans with the crisis management deployment scenario, IP6. IP6 is very important for us to solve some of the issues like nothing, etc. We don't know if we'll actually do that with version 1 because we know you guys have been running IP6 for a long time, but you have kind of a static setup and the crisis management setup is very, very dynamic. So the trucks move around all the time and we're a bit unsure of how that will react with IP6. But BRDP, this is the next talk. This is another stepping stone to solving the breaking connections problem. We will probably do that, but probably not in version 1. Multipath TCP. This is another stepping stone to solving breaking connections. Multipath TCP is getting to be in a good enough state to be merged in the upstream kernel. So we're kind of waiting for that to happen. And besides, before you can use this, you have to put into place many, many pieces of the puzzle before you can actually use it. So multipath TCP is like a multi-year plan for us. And version 2, of course. We really want to deploy version 2. Okay, Henning. Version 2.
Harry, is multipath TCP the same as SCTP?
No.
No.
Multipath TCP.
There's a good article on LWN. I just suggest to read. If you want, I can paste the article on IRC channel.
Quite recently. Basically, you have multi connections on the same socket, basically.
Okay.
This helps scanning the window on TCP in case of...
No, you have sort of like, to put it very briefly, you have a primary connection and a backup connection over a different path. So if this one breaks, your connection on application level does not break because you just start using the backup path. And you
So
immediately
the backup
open
is
another
another
one.
interface.
Sorry?
The backup is following another interface.
Yeah,
Another
maybe
path.
even a different gateway. The point is that you could have...
TCP is end-to-end protocol.
Yes, and multipath TCP allows you to have many ways between your two endpoints, maybe even through different IP paths, IP addresses, and it should be transparent to the application. So you could have, without having a VPN server somewhere in the internet, you could have a multipath TCP connection to someone, and then your gateway breaks down and it doesn't really matter because there are other gateways left.
My next talk will make this a bit more clear.
Okay.
Yes, I would have some
I
questions too.
posted the link on IRC. It's a short article. It's pretty good.
Okay.
Okay, let's switch to OLSR version 2. It has been quite some time I've been working on this, and I decided this time I will not bore you too much with the stuff I've been doing the last year. Yes, I would like to focus a little bit more where we are at the moment and where we need to go in the future, because there are some things we will be able to manage to do with OLSR version 2, and we really don't have any experience. What's the best solution to go for? So what has been going on? So yes, there's progress. The neighborhood discovery is pretty much finished. It's, and the OLSR version 2 part, yeah, I would say yes. Sending processing has been done, I would say, for 5 hours. And with this done, I noticed that here's still some bugs. So, but we're getting close to the point that we finally can run a Dijkstra on it. So it's not that far away anymore that it finally does something useful instead of just producing protocol traffic. Okay, what's next? Because we have been working with OLSR version 1, at least in the OLSR org implementation. Okay, let's see if this works. Yes. And we have been holding back quite a number of ideas because the current code base cannot really support them without breaking the whole stuff. And we said, okay, we want to move to OLSR version 2. We have to break, most likely we have to break everything. So we don't want to break everything twice. People will not like to break it once, and when we say to them, yes, we break it once, now for your new routing metric experiment, and 1 year later you will break it again for OLSR version 2, someone will tell us, no, we will not. Wrong direction. So first thing, the new implementation is directly dual stack capable. So you don't need to run 2 routing daemons for IP version 4 and IP version 6. It's only one thing, and you can configure to run IP version 4, IP version 6, or both of them at the same time. There's no need for some tunnels to do IP version 4 or over IP version 6. It will just redistribute both IP version 4 and IP version 6 information and routes. If you want, so you can switch off both of them. And I try to be compatible with settings that use only IP version 4 or only IP version 6. So the idea is that you can have lots of dual stack nodes, and maybe you have a few of them that only participate in half of the network, and they will never know you are dual stack capable. They will just ignore some protocol messages, and it should work out fine without them even knowing. Hopefully even for implementations that are not OLSR.org. I've already done some interoperability tests for the NHTTP part with the NIL in the US, and after some bug fixes on both sides, it worked out pretty well. Routing metrics. I think we can all agree ETX is not really great, but it's the worst metric that works. The problem is many other metrics that have been proposed, we know they don't work that well. A lot of them have been designed in small artificial setups. Some of them have been designed in simulators, and we know simulation is nice, but there have been quite a few simulations that have nothing to do with reality. And so people designed great protocols and they designed great metrics, and then someone put it into real hardware and said, okay, yes, was a great idea, but please keep it in the simulation and don't do this here. So ETX is nice, but what's about link speed? Where Wi-Fi has always been a dynamic link speed, and the dynamic range grows, and at the moment ETX considers a 1 megabit link the same as a 100 megabit link. With some problems we heard yesterday, you have long range links which have some of them have a really, really low data rate, and the problem says, well, no packet loss there, 2 hops to the target. Let's put all our YouTube traffic over this 2 megabit link. That doesn't work out that well. So, and what about link stability? At the moment, ETX says, yes, this link has this much amount of packet loss at the moment. But if I have a link that has a little bit packet loss and has been up for 10 hours, no change, and I have one that has no packet loss at the moment, but 30 seconds ago it was gone for 20 seconds, and 5 minutes ago it has 80% packet loss, and an hour ago it was gone for an hour, I would say, okay, maybe we should reconsider what is a good link. Just measuring the current packet loss is not the whole picture. We want maybe to look a little bit that we see if a link behaves in a randomized way, we might not want to put that much traffic on it, unless there's no other way. So, in fact, we cannot get really stable links. Okay, maybe sometimes we are lucky, we have stable links. What we want is a stable description of a link. So if a link has a packet loss that jumps up and down between 20 and 80% all the time, it would be nice to have a stable description for this. That we say, yes, this is a link, and we give it a fixed cost, and as long as it doesn't stop jumping up and down, we don't need to change this. This will of course help us to make the network a lot more stable. At the moment we are transmitting a lot of noise. A few weeks ago I did some calculations. I tested out my NHTP ETX implementation, and I set a bridge to 50% packet loss, and I noticed, yes, the ETX value is jumping up and down by 20%. I said, okay, this is a perfectly stable link. It's just a randomized dropping by 50%. And when you look into the statistics, you notice, yes, that's normal behavior because I didn't have enough measurement points. I have only binary decisions to measure the ETX value, so I can expect some amount of jumping back and forth. And this jumping back and forth is not an information we want to transmit, that's noise. We should not transmit this kind of information. We need to look for ways to filter this out. We are interested in a relevant change of a link, whatever relevant means, but we are not interested in wasting our time transmitting things that are not meaningful anyways for us. So yes, we want stable descriptions even for the unstable links. If there's some way to give a cost value to some insanely jumping up and down link that still transmits a little bit information from time to time, that would be nice. Multi-topology routing. Question always, yeah, routing metrics, what is the best routing metrics? ETX is not that bad. And if we put in link speed, then we have some kind of airtime metric. We measure how much airtime we waste by transmitting this stuff. But is this the best routing metric? Yes, maybe. Sometimes. What about FTP downloads? Yeah, ETT or ETX, we want to have a high data rate connection for FTP downloads, or maybe some HTTP downloads. So we don't really care if this stuff goes over a lot of hops and has some delay involved. We care about data rate. What about voice over IP? Voice over IP, yeah, high data rate is nice, but if we have too much delay, we cannot use it. So multi-topology routing is the idea that you can have more than one routing metric in the same routing protocol on the same links, distributed with the same protocol, and then just run the routing calculation twice in different routing tables. So you could use, for example, policy routing to say, okay, all voice over IP traffic, I use a different topology. One where I'm sure that I don't use links that have problems I don't want to handle with. The implementation will support this out of the box, so we can even use it to compare two routing metrics. When we say, okay, we had a new idea, we have a tweak on the routing metric that might be better, just add both of them to the routing protocol at the same time, and we can run comparison to the same protocol. MPRs, yeah. I know MPRs are something like, please don't get some picture and don't start some wood to burn me. I know MPR has a really bad history, but if we think back, the time I wasn't involved in this. The time it was tested, we have tested it mostly with hop count metric, and a little bit later, it was discovered, okay, if we use hop count metric, it doesn't matter what we do, it will not work anyways. So, yes.
Please short say what it means, MPR.
Okay, how many people don't know this MPR story?
Hey, you have to be into OSR to know that.
Okay,
Yes.
It's called multi-point relays. The idea is, when I want to reach the network, I have, in theory, lots of one-hop neighbors, even more two-hop neighbors, and most likely when I want to flood information, I don't need every of my one-hop neighbors to repeat everything I say, because most likely there's some overlap. At least that's the way when you use omnidirectional antennas. So the idea of MPR was, hey, I calculate a minimal set of one-hop neighbors to reach my two-hop neighbors. And the proposed, the example algorithm does this all the time. It changes every few seconds. It tries to optimize things, and with the result, it breaks down regularly. So, yes, the proposed MPR algorithm isn't really that good, and most likely in our point-to-point link networks, it will not even matter. But I think smartphone-based networks, MPRs will really become important. If you have a room with 20 mobile nodes speaking a mesh protocol, you don't want them all to distribute routing information over the whole room. You don't want them all to retransmit data. You want a few of them, and the rest should please shut up and don't waste airtime. So we should look into if we can build an MPR algorithm that focus on first on stability and then on some optimization. We don't want to change the MPR set just because it might have a 5% better chance to get to the neighbors. And if we change it, we have to be careful not to drop stations of the old MPR set before we are very sure that the new stations finally got the idea that they should forward traffic for us. But I think this might be, especially for networks that use omnidirectional antennas, this will become important and will be a good tool if we find a good algorithm to reduce the traffic in this kind of networks. Link hysteresis. Yeah. In OLSR version 1, link hysteresis was some kind of ETX metric, I would say, with a memory of 3 packets. So it was saying, yeah, I try to average over the packet loss over the last 3 packets, and if the packet loss goes beyond 70%, I drop the link, and if it goes back, the packet loss to 20%, I get it back again, and it fluctuated up and down, horrible.
It was only binary. It's either I like you or I don't.
The result is binary, but the result comes from an exponential aged reception. It's pretty much the same we do with the ETX float metric in OLSR, just that the factor which defines the length of the memory was in the standard that insane that it was totally useless. Hey, losing 3 hellos in a row, you can just calculate, even if the link is good, you will, after some time, it will happen, and then you will lose the link. So, no, we don't want to use this kind of link hysteresis, but are there links in our network where we say, no, we don't want to use this link at the moment? I'm not sure about this. I'm not sure this is a useful tool for all kind of networks, but maybe there are some reasons why we say, okay, we have some daemon that says, okay, now this kind of link, let's wait a few moments before we make this a symmetric link. Let's keep an eye on it. I'm not really sure. This might be a tool where we don't need it. But it's in the standard, so implement it, but like all the other tools, it will be a plugin. The standard implementation will just say, okay, there's a new link, just activate it, and never deactivate it again without overhead. The question is, do we have really unstable links on our networks where we can say, yes, this guy built up a network link and we looked at it and this damn link, it breaks down every 2 minutes. If we have these links, if we can measure this, maybe we could look into that we block this link of the network. Or maybe make it, blocking links of the network is always, there's been lots of discussions, even at the ITF about this. And the counter argument is always, what if it's the only link that connects you to your destination? It might be a shitty link, but a shitty link is better than none at all. So link hysteresis is something I'm not sure what we will do with it.
Why not just forget it?
Because I don't want to throw it away before I've tried to do something with it, and we will have some. There are some when you do signatures on the protocol traffic. This might be a place to maybe an easy place to implement this. When you do something like the secure plugin, you could say, I don't let a link become symmetric unless I check the signature or do some handshake with my neighbor. There are networks like when you do meshing for the police or for the fire brigade, you maybe don't need to encrypt them, but you definitely want to do a signature on a message level, so not any person with an IP capable radio in the right frequency range can insert protocol traffic. And this might be a way, this might be a place where you could hook this into the protocol. Multicast. Yeah, I know multicast is difficult, and even in Linux, documentation, what you can do with multicast forwarding in the kernel is at best outdated. And the worst thing you discover, hey, there's some protocol option to support PIMD version 2. And you find a documentation file that is just a summary line that says PIMD kernel support. Activate or deactivate, and nobody really wrote the documentation what is going on. But maybe there's some better way to do multicast than totally in user space as we do it at the moment. We have definitely people caring for multicast, otherwise we would not have 3 multicast plugins, or maybe 4 or 5. I'm not sure. Maybe someone wrote it but didn't told us about. But that's an area we really should look into again, if we can clean this up and maybe integrate it smoothly into the operation system. So I would say we're living in interesting times, and we have to see what we make about it. There are lots of things we have not looked into in the whole orders out of project history. And I think there are quite a couple of things that can make the networks more stable and more performant. But we have to test them out before we can say what we need there. Questions?
Everyone's flabbergasted.
Do you have a sense of when like OSR version 2 will be like kind of ready to go ahead and run on a test network?
Last year in December, you said.
I would say I tried to answer this question a few times, and most times I noticed no, I didn't manage to do it. It has been, I would say, if I had known how much effort it was to completely rewrite the orders R code base, then I'm not sure I would have done it. Luckily, I didn't know when I started it, and when you have spent a year on cleaning up some basic code, then you don't want to throw it away anymore. So, but let me jump back. At the beginning of this year, the code began to do useful stuff. So the neighborhood discovery started working. It had some pretty creative bugs in it when I tested it against the NRL implementation. And the OSR version 2 code has been doing some interesting stuff for the last weeks. So at the moment, this year this processing is already a little bit further. It finally transmits and receives data, which, because it's a new code, there's still some bugs involved somewhere, I think here. But if I get to the point that it finally distributes all this topology information, then it's just implementing a Dijkstra on top of it and setting the routes. The code to set routes in the kernel is already there. That was one of the basic parts I finished a lot earlier. So, yes, I hope so soon.
Sorry, I know it's a terrible question to ask.
Yeah, I know, and I've been not. I was sure that I would get it more quickly done in the last years, and it was a headache to try to do so.
Well, you can jump in and help.
Sorry, I've been late to your presentation. So what are very new, exciting differences between OLSR version 2 and the previous version. Can you just give me a short primer, or shall we do that later?
I think we still have some time. One thing is that they found that they change. It's in fact the same protocol. It's the same idea, just I would say updated with feedback and experience from the last roughly 10 years. So one thing, they directly integrated support for linked metrics into it.
So
And they didn't integrate the support for special linked metrics, but they said we have a generic encoding for cost value, so you can put any kind of link metric into it without changing the protocol.
So
They cleaned up the mess with the MID messages. There are some crazy, strange things that can happen with the messages of OLSR that tell you what interface addresses a node has, because you sometimes have the you hear hellos, you hear station, hey, that's station A, you hear another hello, hey, that's station B, and then you hear MID, and it says, okay, that's the same station, in fact, and you begin to reshuffle your database. So they try to simplify the protocol structure by reducing the number of protocol messages from 4 to 2. The new method structure.
Henning, the problem is if you use all those OLSR specific terms, those people not familiar with OLSR will not get it.
So, for example, we have some ideas to calculate the value of a link, but we cannot use those values with OLSR version 2 because there is simply no place to put these values into the messages. For example, we know the speed of a link, but there's no chance to transmit this and to make use of this. But it's important, like Henning said, at the moment a link with 1 megabit width is perfect, and a link with 100 megabit width is perfect is for OLSR simply the same from the calculation side.
I know that.
And that's, from my view, a very important thing to get into OLSR version 2, because we have a more open format of the messages.
Yeah, we need way more information from the lower layers to be able to have a better link metric. For example, the link metrics in our network, which is highly dynamic, will work very differently from those in Linux, which is more of a static setup. So we want to deploy a different plugin for that than they will. And in version 1, forget it.
You could do it in theory in version 1, but you break the whole protocol every time. Years ago you broke.
We already broke it.
Yeah, you already broke it once for ETX, but the
8 years ago.
Yeah, and the way it's encoded can only transport ETX well. So it will not work for any other routing metric because it's hard calculated in link quality, neighbor link quality in a very small range. And so, if you have, for example, if you have a mobile network and you say, yes, I would like to know the relative speed of my neighbors to adjust my hello timing settings. When I notice, oh, this guy is moving compared to me, I better pump out a little bit more hellos. There's no place where you can put data like this into existing messages without breaking them, because they are all binary format without any kind of meta information. The new format always have type information and length information for every value you put into. So old parsers can easily skip new data because they say, okay, there's this address and there's some data attached to this address and I have no clue what it's about. Let's just skip it and go to the data I care about. And so if you be a little bit careful, you can easily add data to existing protocol messages without breaking the protocol.
And
in fact, the multi-topology extension is exactly doing this. It's using the same data as a standard protocol and just use the extension idea to enumerate the different topology numbers.
And it will also make your deployments a bit easier if Like if you have a breaking change in one of your plugins and you version that correctly, then you can just slowly roll out that without breaking the rest of your clients. You don't need to upgrade your complete network at once, which you now have to do. So it will make a lot of stuff easier.
But it will add some overhead to your package size, of course.
Well,
But I think in reality the overhead of the packet size is nothing we have to care about, because we have a lot of fewer messages in the new protocol. So that's not the point.
Why is there fewer messages now? Because you have 2 message classes instead of 4?
Yeah, and one of them, which was formerly flooded through the network, will not be flooded anymore. And the new format has an address compression scheme. So if you have lists of addresses with common prefixes or a common suffix, you can just put it once in there. And this might be, especially for IP version 6, interesting, because most likely you will have a network prefix and it will be all the same for all the nodes in the network. And it might, and in the end, maybe you have for every node you have a /64, and so you have 8 0 bytes at the end of each address. In effect, you must transmit 2 or 3 bytes for each address, and you can do this with the packet format.
And not to forget that the idea is to only transmit relevant changes of links, and not every second say, I'm perfect, I'm perfect, I'm perfect, I'm perfect. This saves a lot.
But that's not a part of OLSR version 2, that might be an extension to
Yes,
it.
of course.
OLSR version 2 is in fact the same idea of OLSR version 1.
You're still flooding the whole topology to every possible
Yeah, that's
node
link state.
redundantly.
Yeah, and that's
with the only limitation that you're trying to reuse multi-point relays again. Or still.
Well, that's one of the things I would like to have a prototype of an OLSR version 1 implementation, which does, for example, do not flood the information if nothing changed, because I introduced another mechanism on one-hop base to make sure that the information gets not lost. So I can, if I have stable networks, the network suddenly shuts up because it doesn't send TCs anymore. Maybe one in half an hour, because if there's no meaningful data change to transmit. But again, to introduce this, I would have to break OLSR version 1 protocol language again, and OLSR version 2 I can just add it to the
excuse me.
Yeah.
The redundancy that you have at the moment, because you're sending those protocol messages as broadcasts, then they get lost. So you have to have some means of synchronizing that you actually have the actual state of the network, right? Because
at the moment,
if there's no redundancy and no repetition of those messages, some new node must learn about this topology.
Yeah. At the moment, what is one major pit trap we fall into is that OLSR combines the compensation of packet loss and the transmission of new information into the same mechanism, just repeating the the topology information every few seconds. And typically, when something didn't work that well, the solution was, okay, send more TCs. And we have to decouple these 2 paths. And I think this can be done.
I can tell you from experience, if you go down the route of only sending out a change once, then you will need reliable multicasting, which is actually quite complicated. It will open a whole new can of worms. I've done it over satellite communications. It's not fun.
But you don't really need. There are simpler solutions for link state protocols than doing reliable multicast. What I've been doing as an experiment, for example, was that similar to my hellos that I talk to my neighbors, I tell them from time to time which nodes in the network I know and what is the version number of the topology data I got from them. It's already in the OLSR protocol, and this information I exchange them only with my neighbors. So this kind of data exchange is pretty cheap. And when I notice I have a neighbor and this neighbor says, okay, hey, this guy knows a newer information than me, so most likely the flooded data got lost, I can send him a unicast, say, okay, please send this information again, I didn't got it. That even goes further. If you have a new node, it comes online, it doesn't have any information, it sees the first other node, and I send him a unicast and say, okay, transmit me everything you know, because I don't have anything. Within a fraction of a second, you have the full-blown topology locally. And you only need when the topology data doesn't change. So if you get the noise out of the data you want to send, then you don't need to a new flooding. You just from time to time say, okay, this is my view of the topology data for this node. Or even if you have a completely standard network, I say, okay, this is a hash about my whole topology table. So if this has changed, we should maybe talk to each other. Something did go wrong. When a change comes, you flood it once, which normally goes well. And in small parts of network, if it doesn't go well, there should be some mechanism to make sure it's locally compensated.
I'm not going to bore you any further.
I know what you wanted to say. We have been there a few times. Good. Any last questions? Good. Everyone is already gone. Dan, thank you. Oh, yeah. Interesting stick.
I might want to use it again for the next presentation.
Yeah.
Your machine.
Yeah, no problem. Yeah. Where do you get it?
At the, it's called the office center or a state.
Yes, I'm coming.
It's just a laser pointer with
Yeah. And then cursor up, cursor down, or something like this. Yeah. So it just pretends to be a keyboard.
Yes.
That's really nice. You have to send me the URL where you got this.
Staples office center.
Yeah, we can look at it. We can look it up later. So you can run it on again.
You probably can. I see your tiny car.
Actually, I realized this.
The one
Yes, me too.